Bradford. My name's Katie Bradford. I've taken over for Peggy Compton as the program manager for Water Action Volunteers. I gotta click to my next slide. And Emily, do you want to go ahead and introduce yourself?
Hey y'all, my name is Emily Heald. I am the Rivers Educator for UW Extension, and I work primarily on the more advanced monitoring side of WAV. So things you can do if you've been in the program a few years, like nutrient monitoring or continuous temperature monitoring. And I also coordinate aquatic invasive species monitoring on streams.
Awesome. And then we also have a picture here of Sean, he's a junior at UW-Madison. He has been our student assistant for the semester, helping get all the equipment inventoried and packed and shipped out to everyone for our new volunteers and resupplying everyone's kits for this year. So that's who the team is. We're based in Madison, but we support volunteers and WAVE coordinators all over the state. So today, what we're going to cover, we're going to do a very brief summary of last year's WAVE program, share some resources with you, and then we are going to walk through getting started for the year at your stream site, the 5 core stream monitoring methods, just to make sure that we're all on the same page and following the protocols to collect high quality data. Emily's going to talk about aquatic invasive species monitoring and opportunities to support that work, and just a few things coming up for this season. We're going to keep everyone muted during the refresher, but if you have a question or comment, drop it in the chat. And if you'd like to speak your question or comment, you can raise your hand or drop in the chat and let us know, and we'll definitely let you do that. We'd love to hear from you. So just want to start with this painting that Marie Jensen, an undergrad at UW-Madison, did for us over the winter. She titles this Repairing Community, and that's what we all are. Volunteers helping to, be stewards of our local waters. We are a citizen science program, and, we really couldn't do it without all of you. There's 88,000 miles of streams and rivers in Wisconsin, and, stream biologists can only cover so much. And really, restoration and protection of our streams and our water quality is a community effort. And I know many of you go above and beyond your monitoring to really take care of your local streams and help engage others in that effort. So just wanted to say a quick thank you for everything. And I hope you have a really great season ahead, and get a few maybe friends, family, neighbors involved in this effort. So just a quick summary of the WAVE program and 2021. As a reminder, we have 3 core roles in this program. Baseline volunteers. As a baseline monitoring volunteer, you all collect temperature, transparency, dissolved oxygen, and stream flow once a month from May to October. Biotic index is collected twice a year in the spring and in the fall. And then some of you, about 20 people last year, did habitat assessments of their stream. So this isn't as common. It requires more advanced training. And it only needs to happen every 5 years or so, because the stream habitat shouldn't change too drastically in that period of time. Our second role, kind of type of monitoring, is what Emily was managing, the more advanced monitoring or special projects. These volunteers collect nutrient samples at strategic sites throughout the state, and those nutrient samples are tested by the State Lab of Hygiene, or in some cases another local lab, for phosphorus and nitrates. We also have continuous temperature monitoring, which some volunteers do, again, at particular sites each year. And that entails deploying thermistors or temperature sensors in the stream and checking on them throughout the year and removing them at the end of the year. That data is then downloaded by DNR staff or by Emily and entered into SWIMS. We then have aquatic invasive species monitoring, which Emily is working on developing a more robust program for that in the future. And she'll talk a little bit about what is happening now. And then there can be other unique projects that volunteers support, like road salt, chloride, pollution monitoring. And then lastly, we have our really important and critical WAVE coordinators, and they help support all of you with, equipment resupply, training, just all kinds of support. And they're really important to us because Emily and I are just two people supporting an entire state of volunteers. So we really rely on local coordinators for that local expertise. And I'll emphasize that again in a second. So in 2021, this is just a recap and a map of all of our monitoring sites across the state. We had 279 baseline monitoring sites recorded in SWIMS that you all submitted data for. Those are the green dots on the map. We had 111 nutrient monitoring sites where samples were collected and sent to labs for testing. Those are the, I think those are the orange dots. And I believe this only includes the samples that were sent to the State Lab of Hygiene and entered into SWIMS, so entered into the DNR database. And then there were 60 plus thermistor sites. Those are the purple dots. And if you'd like to, dive in and explore this map, interactive map, it is on our website, and I'll show you where that is right now. So if you go to our homepage of our website, you want to see data from last year. You hover your mouse over the data tab at the top where the yellow arrow is pointing, and you'll see a drop down that says WAVE stream monitoring sites. That's where you can play with the map. There is baseline and nutrient data PDF reports. I haven't yet posted those for this, for 2021. I've been encountering some errors with our system, so I'm going to be able to work on that likely after the spring training season, and we're hoping to have a more interactive data tool soon anyway. So that's coming, and then there's continuous temperature data, an interactive dashboard as well, so you can explore all that there. Any questions before I move on, or questions or comments on that around 2021? Nothing yet. All right. So let's talk about getting started. As a reminder, the expectations of our WAVE baseline volunteers, for one, safety comes first. So if you arrive at your site and the water is super high after a storm event or snow melt, or there's some other reason that you don't feel safe there, then don't monitor. We'd rather you skip it and come back another day than put your safety at risk. The second ask is that you monitor your stream site once a month from May to October. Sorry, my phone's going off. I don't know if you hear that. So that would be 6 visits. We recommend that you schedule your stream visits ahead of time. So for me, I've already scheduled mine for like the second Saturday of the month at 9:30 a.m. and I'll come back that same time and day every month. We ask that you submit your data promptly into SWIMS after each visit. So don't wait, because you may lose your data sheet, or the end of the year may roll around and the holidays, and all of a sudden you run out of time to submit your data. So just do it right away when you get home, if possible. 4, take care of your equipment, check for expired chemicals. And 5, report suspected aquatic invasive species. Emily will talk about that in a bit, so keep your eye out for those. And then lastly, if you do work with a WAVE coordinator, just stay in touch with them and let them know how you're doing. We, again, really rely on WAVE coordinators to support you. So we want to make sure that you're in touch with one another. And we have a question, what do you do with expired chemicals? Yes. So if your chemicals are expired, they need disposed of safely, and the reagents need to go to toxic waste disposal. And I can email you info actually about this. And then the sodium thiosulfate and starch can be diluted and poured down the drain. So and I already covered all these, great. How important is it to use the same day each month? You can adjust the date a little bit. Day, for example, if you can't make it one Saturday, you want to do it on a Sunday or a Monday, that's totally fine. Time of day is more critical because temperature and dissolved oxygen fluctuate on a daily cycle. Date, I would just suggest, we want to make sure your sampling is spread out by about a month. So trying to be close to that, same weekend or weekday each month, as close as you can. We know life gets in the way, so we'd rather you not skip your sampling for that month just because you missed the day. Here I created a PDF, which is on the website, listing our 2022 WAVE coordinators. This is a map showing where they're all located. The kind of orange pins are some of our new coordinators who are coming on board this year. So we're trying to fill in gaps in different parts of the state. We have 40 who are active. They cover 56 counties. So obviously we still have gaps, particularly in the northern part of the state. And that's something we're working on. So get in touch with your coordinator. They can help host baseline stream monitoring training. Sometimes it's one-on-one, sometimes it's as part of a group. They distribute equipment. They can help locate stream monitoring sites, communicate program changes. So I'll email with our WAVE coordinator group, and so that everyone's on the same page. They're really the first line of contact, and they can help expand, the experience for volunteers by connecting you with local opportunities of different kinds, hands-on volunteer opportunities, restoring streams or educational opportunities, that kind of thing. I see the question about how trainings are coordinated for habitat assessment. Right now, it's just if a coordinator has been trained on it, they might provide a habitat assessment training for their local volunteers. Emily and I, since we're new to this program, we're actually getting trained on the DNR biologist methods for doing habitat assessment tomorrow. And then we'll be talking about how to potentially provide trainings to volunteers on this throughout the state. We would probably train coordinators who would then train volunteers. So that will be coming, probably not this year as we're just kind of getting things rolling, but hopefully next year. TBD, this is coming soon. So we'll keep you posted as we develop that. And then we have a few new resources on our website and old ones. I just want to remind you that are there. On our website, you can sign up for our now monthly e-newsletter. This is where I send out all the important information about the program. You probably heard about this training from that newsletter, but if you're not on it yet, I highly recommend you sign up. We also have data sheets, methods, fact sheets on the website. So if you need to print data sheets for the season, you can go there. And I recently posted a video walkthrough of entering data into SWIMS. That's on our website under video library. So you can watch that if you need a refresher on entering data into SWIMS. We aren't going to be hosting any training because we would basically just do exactly what we did in that video. In 2021, after the end of 2021, we did data quality checks. And basically, we just check 10% of the stream monitoring events and look at data sheets that folks send in. So a few reminders as a result of that effort is to fill out your data sheets completely each time. So at the top of your data sheet, remember to fill in your station ID, your station name. This is exactly what is listed in SWIMS, date and time, and then fill it out completely for all the parameters you're collecting for, and save your data sheet. So we ask you to either send them to your coordinator or mail them in directly to us, and your coordinator will mail them to us as well at the end of the season. And that's what we use to help us do our data quality checks. But data quality was excellent, and we only have a few reminders sprinkled throughout today's training that are a result of things we saw during the data quality checks. If you have any issues entering data into SWIMS this year, your first step should be to email the DNR SWIMS team, dnrswims@wisconsin.gov. It can take them a few days, sometimes a week to respond. It depends how busy they are at the time, but they will get back to you. You can email them for things like fixing a data entry error, troubleshooting any SWIMS issues or errors, connecting your user ID, your WAM's user ID to a new stream monitoring site or station. So if you're monitoring a new site this year or want to add a site, then they would connect you on SWIMS to that site. Okay. So any questions before I move on? All right. So let's move on to arriving at your stream site for the season. This is all kind of refresher and reminder on the methods so that you're ready to go for the season. So when you arrive at your site, remember to choose a stretch of stream at your station where the water is flowing freely and normally and is really representative of your station. A stream station is actually 300 feet long. More than likely, you should be coming back to the exact same spot you were at last year on your stream station. But if you're getting to a new site this year, you want to drop a flag at a stretch of the stream, again, where the water is flowing freely and normally. And you can also, mark it in different ways. You just are marking it so that you can come back and sample at that exact same spot every month. And as I mentioned before, you want to fill out the top of your data sheet completely right when you arrive. Make sure you're listing, the people that are monitoring with you, their full names, and noting the weather in full. Sampling date, if it's your primary sampling date or if you had to change your date for some reason. Maybe it's a safety date if, your stream was really flooded or dangerous for some reason. You want to indicate the current stream condition too and write observations about your stream site, things that really would influence the water quality or the health of the riparian area or the stream. Those are all important things to note. And our biologists have said that, noting the stream condition, if you have a stream that's all of a sudden low flow one month, or it's significantly flooded and there's erosion happening, that is really valuable for them to know. So on my stream that I monitor, Pheasant Branch Creek in Madison, it's an impaired stream. It's, basically a drain pipe for an urban area. And so we see things like when I went down recently, there was an oily sheen on the sandbank along the stream. So I would note something like that. All right. So our first parameter is temperature. This is the easiest one. Just a few reminders. You're going to walk upstream to your sampling location so that you're not interfering with, the fresh water flowing by kicking up the sediment on the bottom. And you're going to sample temperature, transparency, dissolved oxygen, all at the same spot where your flag is. So first collect the air temperature because the thermometer will take longer to adjust back to the air. So start with that first. Take the air temperature over the stream, making sure to hold the thermometer at eye level. And then take the water temperature. So to do this, you hold the thermometer in the water, low in the water column, so you're not just getting the surface water temperature, until the reading stabilizes. It can take 1 to 2 minutes for the reading to stabilize. And then you're going to raise it to eye level to read the temperature in Celsius. You can fill a clear plastic cup with water to raise it to eye level. I got the question after last week's training, or a comment, what you don't want to do is take a sample of water, carry it to shore, and then stick the thermometer in and read the, let the thermometer adjust to that sample of water, because that's probably not going to represent the actual stream temperature. You do want to hold the thermometer in the stream, and then after it's adjusted, just bring it up to eye level and read it. So that's temperature. And then we have transparency. So for transparency, remember to circle that you're using a 120 centimeter tube on your data sheet, which most of us should be. Those are the tubes that we ship out and give to new volunteers. So once again, you're going to walk upstream to your sampling location where your flag is, where the water is flowing normally. And you're going to fill the tube from kind of the middle of the water column, making sure you're not taking up sediment and avoiding getting that into the tube. If the water is shallow, you can put your hand over the top of the tube to raise it up. If you need to, you need to get the water all the way to the top of your tube. So that can help. You are able to use, if you have a super shallow stream and you need to use a bucket, that is one method you can use. Just make sure you're not, getting a ton of sediment from the bottom. You have to be careful using a bucket, so only do that as a last resort. Really try to just fill the tube direct from the stream. And then you're going to carry the tube to shore. You don't want to wait to do your transparency reading, because the sediment eventually will settle. So we want to do it when the sediment is still suspended in the tube. Remember to stand in the shade and block the sun for your reading. Remove your sunglasses. And you're just going to release the water using the clip until you can just see the contrast between the black and white Secchi disc at the bottom of the tube. And then you're going to record the water level. So looking at the on the image on the right here, I would say that is a 61.4 centimeter water level for our transparency. So you can see there's the hash marks. There's 10 hash marks, larger hash marks, and then there's every 0.2, 0.4, 0.6, 0.8 in between those. 61.4 for that. And then remember to dump the water, and you're going to repeat that. So for transparency, we take the average of 2 samples so that we're really getting a good representation of our stream transparency. So, if my second sample was 62 centimeters, I add 61.4 to 62, and then I divide that by 2 samples to get a nice average of 61.7, making sure you're writing all 3 of those down on your data sheet. All right, any questions so far? Okay, let's move on to some of the trickier methods. Dissolved oxygen with a hot kit. I'm not going to talk about meters today. This is one of my favorite methods. I just love being a chemist. So before you even head out to the stream the first time, double check your chemicals. Are they expired? They should have a month and a year listed on them. So check those before you head out. If they are expired, ask your WAV coordinator for a resupply. If you don't have a WAV coordinator, then you would email us, Emily and I, at wave@extension.wisc.edu. If your starch solution, if there are like particles floating in it, if it's kind of cloudy, clear cloudy, there's a good chance that means it's expired and it won't work. This happened to us at one of our trainings recently, even though it said it wasn't expired. We used it and nothing happened. It didn't turn the sample blue. So we had to replace that bottle. And then make sure you have enough chemicals for the entire year. So for 6 sampling events or more if you have more than one stream site. So the first step in DO is collecting a nice clean sample. So remember to circle hot kit as your sampling method on your data sheet. Once again, we're going to walk upstream to our flag where the water is flowing freely and normally. And you immerse your bottle in the water, making sure to release all those air bubbles, and you can insert the cap while it's still underwater. And before you take it to shore, remember to double check, are there air bubbles? This is the pain of this method, right? It's making sure all those air bubbles are out of your sample throughout many of the steps. And the reason this is important is because we're intending to measure just the oxygen dissolved in the water. We don't want any of the oxygen that's in the air, and that's what air bubbles are. So if you accidentally do the test with air bubbles in your sample, it's going to record a higher dissolved oxygen level. We don't want that. So once you have a nice clean sample, you can bring it to shore to do your testing. And you don't want to delay either, because the longer you delay, the more that the dissolved oxygen in the water is going to be exchanging with the air, and that's going to mess up your reading. So you want to do the testing right away. Put on your goggles and you add DO reagent 1 and DO reagent 2 to your sample as shown here. And then you're going to scrape the chemicals, get it off with the lid off of your sample tube. And then you're going to insert the cap, making sure again that you don't get air bubbles in there. And once you know that you don't have any air bubbles in there, you're going to shake it from side to side for 2 full minutes, really ensuring that those chemicals are mixing fully, because what they're doing is they're fixing to the oxygen samples in the oxygen molecules in the sample. So you want to make sure those chemicals have a nice, good chance to disperse and grab onto those oxygen molecules. And then after you've shaken it for 2 minutes, you set it down and you wait for that flock to settle, which is the brown-orange goo, I'll say. That is an indication that it's working. And as soon as the top of the sample is clear, then you're going to pick it up and you're going to shake it again for 2 minutes. And this is to make sure, again, that those chemicals are fully mixing and they're really latching onto all those oxygen molecules dissolved in the water. And then you're going to wait again for the flock to settle at the bottom. And once it looks like this, you're ready to go to add DO reagent 3. So add it, insert the cap, getting those chemicals off the lip of the bottle again, and shake for 2 minutes. The sample's going to turn orange yellow at this point. So if it looks like that, it's ready to go. And at this point, the sample is fixed, it's stable. So you could take it home if you want to do the titration. The oxygen in the water, the dissolved oxygen, can no longer exchange with the air. So now we're ready to count those oxygen molecules dissolved in the water. To do that, we need to pour out 2 measuring tubes into our square mixing bottle. So write on your data sheet that you're using 2 tubes. This allows us to get our dissolved oxygen in micrograms per liter reading to the nearest 0.5 milligram instead of the nearest 1 milligram. And that is what I'm doing here. And then we're ready for titration. So we get out our sodium thiosulfate dropper. You're going to make sure you're holding it upright and not at a slant, because it may be releasing different amounts in the drops if you hold it as a slant versus upright. Hold it upright and you're going to carefully count every drop, swirling the bottle in between each drop to make sure there's good mixing happening. I suggest that you pause after about 10 drops and add your 3 to 4 drops of the starch solution, which will turn it blue. It's just easier to remember if you stop at 10. You may have your own method. And then you're going to resume adding those sodium thiosulfate drops. So then I would start at 11, 12, 13, and so on, counting every drop and swirling the bottle until the sample is perfectly clear. It can help to hold the sample up against something white so you really see that it's clear and doesn't still have a blue tinge to it. Then we're going to write down the number of drops on our data sheet, and to calculate the dissolved oxygen content in milligrams per liter, you just take the number of drops and you divide it by 2 tubes. So it's pretty simple, pretty straightforward. Each drop is, just divided by 2. And then to write down the % DO saturation on your data sheet, you flip your instruction card over to the back to use this tool. You're going to draw a straight line between the water temperature reading you took earlier and that oxygen reading in milligrams per liter, and that should give you your % oxygen saturation as shown here. So it's showing about a 74% oxygen saturation where this line is cutting through. I suggest that you follow the instructions each time you do this, just to make sure you're not missing a step, something I do each time. There's a lot of steps. Want to make sure that we're doing the process right. All right. I see there was one question. If there's any other questions now, welcome to ask. If we have a YSI DO meter, should we do both methods and record them? Only if you are not confident about one of your readings. Otherwise, you're welcome to just do the DO meter method. That would save you a lot of time. If you're not confident in your meter, then you can, test it out with the hot kit method to see if they're pretty close. Scott also asked a question of me, shaking the sample. I do not see in the extension or hot kit directions that it is done for 2 minutes. Yeah, so you want to do it for 2 minutes. And that is the instruction that we get from the hot company. So you shake it for 2 minutes, you let the flock settle, and then you shake it again for 2 minutes and let the flock settle. All right. Any other questions? Okay, so I'm going to go on to StreamFlow. This is the one we usually get the most questions on, which is understandable. It also has a lot of steps, but it doesn't have those nice clear directions like we have for the hot kit. So what we're measuring with StreamFlow is StreamFlow discharge. This is a very common measurement that people in the industry use, and we're measuring it in cubic feet per second. And the equation there at the top is exactly what we're doing. So we are measuring area, the area of our stream, which is feet squared, and we're multiplying that by velocity, which is feet per second. So the first part of this method is we need to measure the cross-sectional area of our stream. To get a cross-sectional area, we are multiplying the width of our stream by an average depth. And that average depth is calculated by taking a bunch of depth measurements and then taking the average of them. Part 2 is velocity. So this is distance, feet, over a period of time, seconds. So the question where we are answering by measuring velocity is how many seconds does it take for a tennis ball to float 20 feet down the stream? We always use 20 feet for our distance. And I'm going to walk through each of these methods. The float, basically this uses the float method, which if you Google the float method, it's all over Google. It's very, very common to use this method. It's very accurate. And just as a reminder that you notice there were feet measurements, feet units throughout that equation. And so when we are writing down our feet measurements, we're going to write them down in tenths of feet or decimal feet. So make sure you're using the side of your tape measure reel that has decimal feet on it. And the reason we do this is because we want to avoid having to convert inches to feet. Inches and feet are really 2 different units. So kind of what you see here in the image, if we look at our 8 3/4 inches, 8 3/8 inches is equivalent to 0.7 feet. And it's just going to be way easier not to have to do any conversion. So just stick to your decimal feet. Okay, so our first step is to measure the cross-sectional area of our stream for that first part of our equation. To do that, we need stream width. So remember to measure the stream width from the wetted edge to the wetted edge of the stream. You're going to record that in decimal feet, tenths of feet, and you're going to write that on your data sheet. You can use stakes of any kind to clamp the measuring tape so it's taut over the water surface if you don't have enough people. So in this example, I just used a binder clip and attached it to a stake. I've used tomato cage stakes before. Whatever you have on hand is great. That, is taut, can be taut above the surface of the water. And then we need to get the second part of our area, which is depth, taking our average depth. So you're going to start at one side of your stream at the wetted edge, and you're going to record the water depth every foot across the stream. As a reminder, your last measurement should still be in the water. So if you move a foot and you're not in the water anymore on the other side of the stream, do not record a 0 on your data sheet. We're only recording water depth, not land depth. So if you reach the other bank, you're just going to stop. And you're only going to have that many points, depth sample points. What do I have next? So for example, I had a stream that was 11.5 feet wide. So I took a depth measurement at 11 points, 12 points, I guess. And I took a measurement at equal intervals. So you're only going to record the depth measurements on the data sheet and in swims. You're not going to add extra zeros anywhere. And swims will auto calculate stream flow discharge from this info. Now you'll note that 0.1 is 0. And what that represents is 6 inches on either side of each stream bank. So you're going to have to enter that 0 into swims, but you don't have to enter it on your data sheet because it's already there. I don't think I have, no, I don't. So the reason that we have that 0 there is because anytime you're taking a depth measurement with your net, you're actually taking an average of depth on 6 inches on either side of that. And so if you were to draw this out on a piece of paper, there would be a gap on either side of the stream because you're starting 1 foot in. So that's what that 0 is representing. It's representing the stream, the depth of water at the stream banks, basically. Let's see. So if your stream is more than 20 feet wide, we only have up to 20 depth measurements. So you're going to have to divide your stream into equal intervals. The reason we need equal intervals is because you don't want to over-represent, particularly deep section of the stream or particularly shallow section of the stream by taking more depth measurements in that area. So we want to spread them out evenly. So for example, if you have a stream that is 23.5 feet wide, you're going to divide that by 20, and then you're going to get some really terrible number, most likely like 1.175 feet. To avoid making errors, I suggest rounding that up to the nearest 1.25 feet or 1.5 feet. Make it easy on yourself. And so if I round up to the nearest 1.5 feet, that would give me 16 measurement points. All right. Any questions about that piece before I move on? Okay, great. So the second part, we have our area part of the equation done. Now we need to do velocity. So we are going, you may have already done this at this point, but just to separate them out clearly, at this point, we're going to mark with our measuring tape our 20-foot length section. And you're going to do this on 10 feet on either side of where you just did your cross-sectional area. So 10 feet upstream and 10 feet downstream. That's your 20-foot length. You're going to fill your tennis ball halfway with water so that it sits nicely in the water column rather than on the setting on top of the water. And then you simply use a stopwatch and you time how long it takes the tennis ball to float that 20-foot length. And you're going to repeat that 4 times so we get a nice average velocity. Remember to start the tennis ball a couple feet above your first flag so it gets up to speed with your stream. And you're also going to want to have the tennis ball float in different parts of the stream so that you get a nice representation of the water flow across the stream. What you don't want is the tennis ball to get caught and stop flowing, because that's not a good representation of stream flow. So you want it to float down how the stream is flowing normally. One person said, I stretch a rope tight across the stream with 1-foot red markings. That makes it easier. That's a great idea. Yeah, you can definitely do that. You don't have to use the tape measure as long as the rope is marked, correctly. What else do I have after this? Oh yes, the correction factor. Don't forget the stream flow correction factor, like I almost did. So this is, remember to circle this on your data sheet we saw in the data quality checks. Not everyone did. And what you have is either a rough or a smooth option. And this is correcting for the friction against the water on the stream bed, depending on what the stream bed is composed of. So if you have a rough stream bed, like there's a lot of rocks or there's a lot of aquatic vegetation, that will create more friction slowing down the water on the bottom. Our tennis ball was floating on the top, so we want to correct for that. Smooth would be like a nice sandy or mucky bottom, or really flat, like granite bottom or bedrock bottom, where the water is flowing quickly over it. And then we also have had questions about streams that dry up and whether to submit data and swims on that. So we have intermittent streams and there's ephemeral streams, and these are 2 different terms. If you have an intermittent stream, the stream is usually wet. So, you go back every month, it's usually flowing, but then 1 month, it has low or no flow. So what do? You can't do stream flow. The biologist said they still want you to submit a fieldwork event and swims and note that it's in a dry or low flow period. It's really valuable for, people doing watershed restoration to know about that kind of change. If you have an ephemeral stream, these are streams that are usually dry and, having flow happens only occasionally. These are not streams that we should be monitoring. So you want to move to a new monitoring station if you're on that kind of stream. And then I think this is the last thing I have. Yep. Whoops, sorry. And I just wanted to share, did you know, some of you I'm sure do know this. You've been doing this longer than I have. So the stream flow float method, while it's commonly used, it's well known that it over measures stream flow by 24%, and SWIMS automatically corrects for this. So if you want to compare the stream flow reading you're getting to a local USGS stream flow gauge, then you need to account for that 24% difference. And I did this recently when I went out on my local Pheasant Branch Creek. We did a stream flow with the float method. We have a stream flow gauge by USGS, maybe quarter mile away. And I corrected for the 24% difference, and it was exactly the same. So it works really well. Now I see one question. We often have surface plants blocking much of the stream in the later season. Should we try to clear out a place for the ball to float down? And yeah, my recommendation is yes, if you can, you don't want to rip them out of the stream bed because you want to maintain riparian vegetation. But if you want to cut back the top of the plants so that, you can do your testing, then that shouldn't affect anything. Just don't do any major work on the stream. You want it to be pretty natural. Any other questions before I hand it over to Emily? Okay, Emily, if you just want to let me know when you want to switch slides, then I will do so.
Thanks, Katie. You can head on over to the next slide here about switching gears to biotic index. Biotic index, remember, this is something that we're not doing every single time we're out at the stream site. We're doing this just in May and October. So it's something you only need to do twice a year. And the goal with biotic index monitoring is that you want to sample a diverse range of habitats. So to get that whole diverse range of habitats, first of all, we want you to know that you are able to spread out when you do these samples. You don't have to stay right by that initial flag that you have for your temperature and transparency measurements. You can go about 300 feet around your designated stream site. And we want you to sample from at least 3 different types of habitat, prioritizing the most diverse to the least diverse, as long as you have these available to you at your site. So the most diverse area you're going to find macroinvertebrates or your bugs are the riffles that you have in your stream. And when we sample riffles, we want to sample upstream and downstream of the riffle by kicking the substrate in front of the net for about 2 minutes or about 20 good kicks. The next diverse place that we have in streams are undercut banks. So you can just simply sweep your net under those undercut banks about 20 times. We did that over the weekend and we actually found a crayfish, so that was pretty fun. Another really diverse place to find macroinvertebrates are leaf packs. And when you do this, you can just grab a handful of leaves and let it sit in the tray with a little bit of water, and the macroinvertebrates will slowly emerge. And then another good place to find macroinvertebrates are snags and tree roots. So along these areas, you're going to do about 20 strokes again, kind of just like you would for the undercut banks, but you're doing this around tree roots. Next slide, please, Katie. So after you grab your samples from, your riffle, your undercut bank, your leaf pack, or your snags and trees, when you empty your sample into your little tray full of water, we want you to let that sample rest just a little bit. That gives the animals a chance to emerge. And then after everything starts emerging, you're going to start sorting things. So sort animals into your ice cube tray based on the way they look and similar characteristics. And then you're going to use that key to life in the river to help you identify the animals. Just follow it down. Does it have a shell? Yes or no? Does it have tail spines? Yes or no? And so you can use that key to guide you all the way to an identification at the end. And then when you're done with that, you're going to circle each animal you found on your data sheet. And it's just a presence or absence. It's not total number. So if you found 8 crayfish, that crayfish still counts as 1. I hope that makes sense the way I'm describing that. It's just the number of groups that you find, basically. And then you tally the number of animals circled in each sensitivity group, and you record that onto your data sheet. Pretty straightforward. Are there any questions on biotic? Do you count? What insects? Just those end up in your net. That's a really good question, Bob. Katie, do you have any insight on incidentals that are captured during biotic index?
I guess I don't fully understand the question. I mean, like you can rub rocks, like in the riffle, you can rub them together to get them into your net to count those. I guess the question is if you see them elsewhere. I mean, I would say your goal is to get as much diversity as possible. So if you're sampling in a location and you see aquatic index attached to those rocks, then you should shake those into your net and get them into your sample.
Let us know if you have any follow-up questions on that, Bob. Okay, we're going to Okay, yes. Usually I find caddisfly larvae attached to rocks. Okay, that's good to know. Yep. So you can, that's what we've been doing.
Yep.
Yep. So yeah, go ahead, like Katie said, knock
Great.
those rocks into your net because that is part of sampling your streams as well. If you find species that do not fit into the categories, you don't count them. You are only counting the species that are on your data sheet. So I know sometimes we are finding species that aren't on the data sheet, but if that's the case, then just consider yourself lucky for the day. You've been blessed by a leprechaun. Okay. And any other questions that come up, go ahead and enter them in the chat and we'll circle back to them. But we're going to move on to aquatic invasive species now. So as a part of the baseline monitoring, we ask that volunteers keep an eye out for 4 species while they're out doing routine monitoring. There isn't a specific protocol for this yet. We're just asking that folks simply keep an eye out. You are most likely to see these while doing a biotic index survey, but it's good to check for them each time you're out. And the 4 species that we ask folks to look for are New Zealand mud snails, faucet snails, rusty crayfish, and Asian clams. So those are 4 species that were chosen by DNR as especially concerning species in streams. And you can find identification information for those on the methods section of our website. We do have a handout that includes identification guides to all of these different species. Anything that you do find that is suspect, I recommend that you take a sample since snails and clams can be tough to identify. And then you can bring that sample to your local DNR AIS coordinator. I'm going to put the link to those contacts in the chat box, or you can just easily Google DNR AIS contacts. And there's also a contact information on the new 2022 data sheet. Or if you're confused on who to contact, if you think you found an invasive species, you can always contact us at WAV and we will put you in touch with the correct person. Next slide, please, Katie. And I just wanted you to know about an aquatic invasive species opportunity that might interest you. Every year we host an event, it's called the Aquatic Invasive Species Snapshot Day, where we partner with the Wisconsin DNR and River Alliance of Wisconsin. It's a one-day event where volunteers around the state will gather at local rendezvous sites to be trained on invasive species identification and monitoring methods. And then the volunteers will venture out into groups to predetermined sites to hunt for those invasive species. It's a really awesome event. It's one of the most data-rich invasive species events in the entire state. We gather a ton of valuable information on species distribution, and that helps us better contain and control invasive species. So mark your calendars. This year, Snapshot Day is on August 20th from 8:30 to 12:30. And registration for that is not open yet. It'll be opening in June, and more information about that will be coming through email and Facebook posts from us once registration opens. We just wanted to get it on your radar for now. And I see Katie in the chat posted the DNR AIS contacts by region, which is very helpful. So you can open that up and bookmark that on your website. And then also, Lance, going back to biotic index, yes, you are very welcome to record additional species on the notes section of your data sheet. It's not required though, but if you would like to note that, you can definitely do that. Are there any questions about invasive species at all? Or biotic index, we can go back to that too. Okay, thank you guys.
Cool. All right, last thing to share is that we do already have the Wisconsin Stream Monitoring Award nomination info posted on our website under About. So just keep this in mind throughout the season. If there's someone you know, a teacher, a local business, a youth, a group, anyone that you really want recognized for their efforts for our streams in the state, please submit a nomination. This is a peer nominated award, so we need you to nominate folks in order to celebrate their work. So that is all we have for today. You're welcome to sign off if you're all set. Otherwise, Emily and I will stay on for the next 5 minutes and we can chat or answer any questions. Thank you.